Alright, today our topic is immunology. Now, first of all, would like to know what is immunology. So we must have an introduction to it. Now, it is study of the immune system. This is its definition. But to be more precise, we should know about the immune system and its definition. The definition of an immune system that it is a system of cells, tissues, and soluble substances that can do three things: recognize, attack, and destroy. Recognize, attack, and destroy any entity that could endanger health. And it has evolved to protect virtually all multicellular organisms. Now, it is highly adaptable and it can defend against virtually all types of threats, from as small as a virus, protozoa, bacteria, fungi, and huge parasitic worms. Okay? Now, if the immune system is functioning normally, it gives rise to immunity. Now, what is immunity? Okay. Immunity is actually a term that is derived from the word immunitas, which is a Latin word, and it simply means to be exempt from. But in medical term, it means protection from disease, specifically infectious diseases. Now, first we are going to talk about the immune response. Immune response is actually a physiologic function of immune system. Predominantly, it is a defense against infectious microbes, but non-infectious foreign substances can also cause immune response to become activated. Okay? The mechanism that normally protect individuals from infection can eliminate foreign substances. But one thing is, in addition to this, that can cause tissue injury and disease all by themselves. If an immune system becomes overactivated or there is some abnormal immune response, it can lead to tissue injury and disease. So, if we want to define an immune response in a more broad way, or so a more inclusive definition would be that it is a reaction to component of microbes as well as macromolecules such as proteins, polysaccharides, and small chemicals that are recognized as foreigns. Now, this is regardless of the physiological or pathological consequences of the reaction. Well, under some situations, self molecules can elicit a immune reaction. This is called autoimmune response. Now, before going into detail of the immune system, we must know something about hematopoiesis, because it allows us to know from where did the immune cell come from. Now, hematopoiesis means formation of the blood cells, and it starts in the fetal life and remains till the end of life, which means that it is there all the time. Now, in the fetus, first of all, it occurs predominantly in the first two trimesters in yolk sac, liver, lymph nodes, and spleen. Later in the third trimester, it starts shifting to bone marrow. But after birth, it is primarily the bone marrow that is responsible for the uh, hematopoiesis, but lymph nodes can also play a part. Now, in where does the hematopoiesis actually occur according to the category of sites? It occurs in mesoblast, in the embryonic life, and then shifts to liver and the bone marrow. Now, mesoblastic hematopoiesis. Now, mesoblastic hematopoiesis starts in the fetal life within the first month in the yolk sac, because yolk sac is of mesoblastic origin, and 90% of the cells are derived from yolk sac. Small parts are like 10% are derived from liver. Now, the number of cells derived from yolk sac decrease gradually, and those of the liver increase gradually until the major site becomes the liver. This gives rise to hepatic hematopoiesis. Now, hepatic hematopoiesis occurs after by the second month of fetal life, and almost all the cells that start coming from liver by then, and the yolk sac stops forming blood cells. In the third month, spleen becomes also involved, and in the fifth month, bone marrow and lymph node also start forming the blood cells. Now, it starts gradually shifting towards marrow, and as the time of birth approaches, bone marrow gradually becomes the major organ for hematopoiesis. Near birth, marrow is most prevalent area of blood formation, but again some occurs in the lymph nodes. In the adult life, the bone marrow, especially the marrow of certain membranous bones, are the primary sites of the bone marrow of the hematopoiesis, and 50% of the cells come from the lymph nodes. So here is a very informative diagram. You can see the not only the sites in the fetal life, but also you can see where the hematopoiesis actually occurs. Again, during the first month of life, after the fetus is 1 month old, the hematopoiesis start in the yolk sac here. Now, after 2 months have passed, the yolk sac almost completely stops forming the blood cells. Now, this here. Now, liver starts forming the blood cells in first month, after first month of the fetal life, but it does increases as the time goes by, and after 2 months, the yolk sac and liver form almost same amount of blood cells, number of blood cells. Now, as the time goes by, after roughly 2.5 months, here, yolk sac has completely forgotten the formation of blood cells, and liver starts taking over. And it takes over, and at the same time spleen also start forming the blood cells. As the now after 3 months of after the third trimester have gone, spleen and liver. After the first trimester, spleen and liver form the blood cells. As the second trimester, uh, in the middle of second trimester, bone marrow and lymph node, they also start making the blood cells. It is here, you can see that virtually within at 4 months or sometime after 4 months, within 4 and 4.5 months, spleen and bone lymph nodes, lymph nodes and bone marrow both start forming the blood cells. Now let's go to 6 months. Now in the 6 months, after 6 months, spleen stops forming the blood cells. Liver also start declining uh, its hematopoietic capabilities, and here you can see that the 6 months the graph of the liver is coming down. Similarly, bone marrow and lymph nodes, which had started the formation of blood cells, gradually increase their capabilities. And by the time of birth, liver, spleen, they stop forming blood cells or have very few, very little contribution in hematopoiesis. So then the major organ at the time of birth that is forming the blood cells that is involved in hematopoiesis is the bone marrow. To some extent, let's say 10% or at the most 15%, the uh, blood cells come from the lymph nodes, and this remains throughout the life. Now, bone marrow forms the blood predominantly in the membranous bone. Initially, virtually all the membranous bones form life, like the part, like membranous part of tibia, membranous part of femur. But as the life goes on, especially after, let's say, 50 years, it is predominantly ribs, sternum, and vertebra that form the blood cells, and the tibia and femur, they don't form any form of any type of blood cells 20 to 25 years after, or at, at the most some blood cells are formed not after 25 years of life. So then rib, sternum, vertebra and lymph nodes are left as bone forming areas, and this remains so for the rest of the life. Now next we are going to talk about the origin of the cells of the immune system. First we must know which cells are there and their classification. So there are two types of uh, immune cells, the myeloid and the lymphoid. Now in the myeloid line, which originate from the myeloid line of the bone marrow, are neutrophils, eosinophils, basophils and monocytes. And lymphoid line gives origin to T lymphocytes, B lymphocytes, and NK cells. The dendritic cells have dual origin. We will talk about this dendritic cells later on in other lectures in detail. But currently, they have. We will just say they have dual origin from both myeloid and the lymphoid lines. The function of the both types of dendritic cells that originate from myeloid line and lymphoid line may be somewhat different. Now here is a very informative diagram. Now you can see that there is a hematopoietic cell which is self-renewing. It always forms one of its copy when it's dividing. So it gives rise to two types of cell. One is myeloid progenitor, the other one is lymphoid progenitor. Now the myeloid progenitor give rise to red blood cells, which is not shown here, and well, it is shown here. Sorry, this is erythrocytes, and the granulocytes and monocytes. So here we can clearly see that these granulocytes, monocyte progenitor gives rise to monocyte and neutrophils. Then there we have an eosinophil progenitor giving rise to eosinophil. Then we have basophilic progenitor giving rise to basophil. Then we have a megakaryocyte which gives rise to platelets, and we have then erythroid progenitor giving rise to erythrocyte. The monocyte can become macrophages. Now here is the dendritic cell that arises right from the myeloid progenitor cells. Now the lymphoid cells give rise to again four types of cells. One is the T cell progenitor, the B cell progenitor, the dendrite cells, and the lymphoid progenitor. Now T progenitor you have to take T helper cells and the cytotoxic T cells. Now B cell progenitor you write simply to B cells. Next is the type of immunities. Now in pathological classification or physiological classification we have two types of immunity, innate and acquired. And in clinical classification we have active and passive. Now innate immunity, first we are going to talk about. So innate immunity is the immunity with which one is born. It is present in birth. It is not a learned immunity. And it is not antigen specific. It is a non-specific immunity. Okay? Now it has many type of barriers, like primary, which are mechanical barriers, secondary, which are biochemical barriers, which may be non-specific and maybe receptor driven, and then we have tertiary barriers which are known as cellular barriers. Then we have competitive barriers like other bacteria, and then we have body processes like temperature and inflammation. We will discuss this in time. Now acquired immunity develops after exposure to an antigen or an immunogen, and it is usually not present at birth. It is very, very specific, antigen specific. It is receptor driven, and there is a pre-existing clones, programmed cells that to make specific that initiate specific immune response, and this immune response may be humoral or cellular. Now again we are going to talk about the active and passive immunity. So the active immunity is immunity that antigens are introduced into antibodies are formed, and it may be artificial or it may be natural. Now artificial means that you inject someone with inactive antigen, and the immune response, antibodies and are produced, and this type of immunity can be is called vaccination. For example, tetanus vaccination, pneumonia vaccination, influenza vaccination, many other type of vaccination that we will talk about later on. Now, next is natural. Natural active immunity means that you are exposed to an antigen and you develop resistance or immunity against it, but you will first become ill as response to that antigen. The passive immunity is that you do not introduce an antigen but directly an antibody. Alright, it again may be active or passive, artificial or natural. Artificial means simply injection of a pre-formed antibodies like anti-tetanus serums. And natural, well, secretion of antibodies in the mother's milk. Another example is some antibodies can cross placenta and enter the fetus and give protection to the fetus.